Hi everyone. Okay, so I'm hoping that what we're getting right now is that there are various ways you can write quadratics, and we're able to get different pieces of information from the different forms. And right now we're looking at vertex form, which this first equation, m of t, is written in. So this example is a really simple one. I just want to make sure you're clear on the fact that when we're saying vertex form is y equals a times x minus h squared plus k. When we're looking for the vertex, which is supposed to be at hk, we can read it right off. So in our equation, a is 1/2. That basically tells us that since it's positive, the parabola is going to open up. And since it's 1/2, it's going to be a little bit shorter, less steep than y equals x squared. It doesn't matter that we're using t instead of x. That's interchangeable. You pick your independent variable, if I can remember my word correctly. Okay, so the thing that's a little bit tricky is that the x part is backwards. So you can see that it's built into this formula x minus h squared. So when I see a t minus 1, it doesn't mean that the vertex has an x coordinate or a t coordinate of -1. It actually is at +1. So this sign right here will always be opposite. So the vertex of m of t is going to have a t coordinate of 1. And then for the y value of the vertex, there is no opposite. If that's +2, then this is a positive. So the vertex of that parabola is at +1, +2. Sign changes on your x or whatever variable is there, and does not change on your y or whatever variable is there. So that's how we actually read them off. In this next example, so we're not graphing yet, but just to say, that means that at 1, 2, I have a vertex, and I also know that the graph has this sort of shape. So I don't claim that that's in any way perfect, but that's already starting to get me an okay little rough sketch. So yeah, that's kind of where we're headed with this. In example 2, we're given a parabola in standard form. It's not in vertex form. Standard form, general form, whatever form, standard form. So we're going to practice writing in vertex form. And this is definitely not the most efficient way to find the vertex of this parabola. In the Algebra for Sciences book, they use the -b/2a trick. That's wonderful. If we can factor, there's great tricks. But vertex form is very useful for many reasons, not just finding the vertex. And completing the square is very useful for many reasons. And that's what we have to do to write this in vertex form. So we're going to use this as a chance to practice using complete the square and getting things in vertex form. So given the choice, if I don't say, probably don't complete the square to find a vertex, but you will be asked to do that specifically sometimes, so just make sure you're practicing. Okay, so if we want to write in vertex form, we need to complete the square. And we've done that already on an expression, and it's really going to look pretty much the same here. There are other tricks you can use because there is an equal sign in this. You could move some things over with p of x to get them out of your way. And I actually like doing that, but I find that mixing things up too much just gets confusing when people are first doing complete the square. So I'm not going to do that. I'm just going to make this look just like we did it in the previous section. So first thing we need to do is, to make it easier, let's make sure we have a single x squared. So we factor out the 2. And just close that off. We're going to leave the +1 out of this. We're trying to figure out what constant term we need to put in those parentheses to make a perfect square, and that 1 will take care of itself as we do that. Okay, so now we snag this number. This is our b. We're going to cut it in half, and we're going to square it, which is going to give us 9/4. So we need to add 9/4 inside the parentheses. To make that a perfect square. And then to balance that, we need to make sure that outside the parentheses, we also subtract it. But we have to be doubly careful here because we didn't actually just add 9/4. We added 2 times 9/4, which is really 9/2 that we added in. So we added in 2 times 9/4, which remember you can cancel a 2 out of that. And you get 9/2. So to keep the value of this expression the same, if we added 9/2, we also have to subtract 9/2, which is going to get me to P of X equals 2 times. Okay, so here's the factor step that's so important. If we have X squared minus 3/2 X minus 9/4, we're looking for numbers that add up to -3/2 and multiply to 9/4. And those numbers are the one we used right here, -3/2. Oh, I'm sorry.